this application problem is related to the average value of a function. So the gasoline consumption from 2010 to 2020, so since that is related to the time in year, then when t is equals to 0, that means 2010, the initial year, and then when t is equals to 10, that means 2020, and this is my consumption function. I have a of t that is equals to 0.027 t squared plus 1.80 t plus 30. Notice that the unit is in billion gallons per year. Is this a rate of change or displacement function? Whenever you see an unit per another unit, billion gallons per year, that means the given function is a rate of change. So what is the relationship between rate of change and displacement? So here is my explanation. So if you see gallons per year, that means rate of change because you have a per gallons per year. So let's say you travel 60 miles per hour, that is a rate of change. If you just see the word gallon, that means displacement. So let's simplify this a little bit further. So let's say we have a unit. So let's say, how about I spent $50 today and I spent $60 yesterday. So $50 today and then $60 yesterday. Is this a displacement or rate of change? This is called displacement. Let's just call it DISP, displacement. I spent $50 today and $60 yesterday. So if you give me a time, let's say today, t equals to 0, I tell you exactly where I stand. I am standing at $50. So today, t is equals to 0. I am telling you the location that where I am standing. I am standing at $50. How about a rate of change? So if you see the word rate of change, so the units will be $50. Then I will be, okay, it is, I should not put it in this way. Then that should be 50. I should put dollars per day. If I say I spend $50 per day, then this is a rate of change. So it's a dollars per day. How do you go from displacement to rate of change? So from a displacement function to a rate of change function, you take derivative. And then on the other hand, from rate of change back to displacement, you take an integral. That's the connection between displacement and rate of change. So go back to this function. The unit is in billion gallons per year. So you have a 1 unit per another unit. Then that means that is a what? That is a rate of change function. The first question is, what was the gasoline consumption at the beginning of 2016? So at the beginning of 2016, let's answer this. Let's change to another color. How about orange? So when t is equals to 0, that corresponds to 2010, right? So t equals to 2016, that is 6 years later, then that is t equals to 6. What was the gasoline consumption at the beginning of 2016? So I gave you the consumption function right over here. So the consumption function is a of t. Then when t is equals to 6, so here for part A, when t is equals to 6, I have a of 6. All you have to do is input the 6 to the consumption function, and then you do the math, right? And then you will end up with a number that is billion gallons per year. All right, so a of 6, so this is a 0.027, 6 squared plus 1.80 times 6, and then plus 130, and then that is equals to 141.772. The unit is billion gallons per year. So billion gallons per year. All right, and then how about B? B is what was the average gasoline consumption per year over the period from 2010 to 2020. So that means over a 10 years period. So that means from t equals to 0 to t equals to 10, right? So here is how we answer B. So for part B, and then the average, that is equals to, so since you have to use the average value, so this is a t equals to 0, that is t equals to 10, then you have to do this immediately. 10 minus 0. that is the main part to calculate the average value of a function, right? And then the rest will be just an integral. So the rest will be just an integral. So integral from t equals to 0 to t equals to 10, and then 0.027 t squared plus 1.80 t, and then plus 130 dt. Okay, and then this is equals to 1 over 10, right? And then the integral, okay, let's see. So you have a t to the third power, then this is 0.027 divided by 3 plus t squared 1.80 divided by 2, and then plus 130t, and then close the square bracket such that t goes from 0 to 10. And then you plug in the 10, you plug in the 0. The good news is when you plug in the 0, the whole thing is gone. And then let's plug in the 10. So you have a 1 over 10. 0.027. You can simplify, but let's don't do this in this line. So 10 to the third power plus 1.80 divided by 2 times 10 squared plus 1.30 times 10, close the square bracket, minus 1 over 10. So once you plug in a 0, the whole thing is equals to 0, right? So this whole thing times 1 over 10, that is equals to 0. And then this is equals to 1 over 10, and then times what? This is multiply. Inside the square bracket, we have 1399. Now, let me ask you this. What's the unit? You might say, all right, the integrand is a rate of change. You take the integral of that, so you take the integral of rate of change. So that means you have to go back to the purple node. So from rate, you take an integral, you go back to displacement. Okay, then that is easy. Then the unit is a gallon. Is this true? Let's find out. So this one, you have 139.9. The unit is billion gallons per year. That is still per year. Let me explain why. So the unit is billion gallons per year. And this is the average value. So here is why the unit is still in rate of change. How do you get the 10? How do you get the 10? So to get the 10, here is how. So you have 1 divided by 10 minus 0, right? So this is in year, and then this is in year. And then how about the 1399? So the 1399, yes, you're right. So this function is a rate of change. You take the integral of that, so you are no longer in rate of change. So there is not supposed to be a per in there, right? So you should get 1399 just gallons. I agree with you. So you have 1399 gallons divided by 10 years. And then the unit is 139.9 gallon per year. That's how you get the unit. Okay. All right. So that is the end of this problem and this video. If you think my instruction is helpful, give me a like, share, and subscribe. I highly appreciate your help, and I will catch you all in the next lesson. Signing out.